Today we're going to be looking at composition of functions. When we are talking about the composition of functions, we are looking at two different functions, g and f, and when we talk about composites, it's written as g bracket f of x and then closure bracket. It's read as g of f of x. Depending on the textbook you are looking at, some other write it like this, or like that, and some actually just have parentheses. Either way it's written, they all mean the same thing. So it's g of f of x. We know that g of x is function notation. When we have something inside here for x, all that means is go to your function, in anywhere that there is an x in your function, you replace it with whatever's inside the parentheses right here. The difference here is I'm still substituting what's inside the parentheses into my function. It just happens to be that it's another function. So let's look at some examples. We're just going to start small. We are given that g of x equals 2x minus 4 and f of x equals x squared plus 3. We want to find first g of 4. G tells me which function I'm looking at, so I'm looking at this one right here. This 4 inside is telling me that anywhere in my function g that there is an x, I'm going to replace it with 4. Once I've done that, I'm going to do the math to get my answer. So 2 times 4 gives me 8, and then 8 minus 4 gives me 4. So g of 4 is 4. So if I want to find g of negative 3, it still means the same thing. Anywhere in my function that there is an x, replace it with a negative 3. So this time I have 2 times negative 3 and then minus 4. So 2 times negative 3 gives me a negative 6. And negative 6 minus 4 gives me a negative 10. So g of negative 3 is negative 10. Well, what if I don't give you a number? I just give you a. It's the same process. Anywhere in my function g that there is an x, this time we're just going to replace it with a. So 2 times a, 2a, and then minus 4. This is as far as I can go, because there's not a number that I'm multiplying by. I just plugged in a. I don't know what a is. It doesn't have a numerical value right now. So I end up with an equation as my answer. So what if I make that a little bit harder? I make it g of x plus 2. So anywhere in my function g that there is an x, I'm going to replace it with x plus 2. I'm going to do 2 times x plus 2, which means I need to distribute, so that 2 needs to go to both terms inside of my parentheses. And then I have 2x plus 4 minus 4, which is just going to give me 2x. Again, since I didn't have just a number inside of this parentheses, my answer isn't going to be a number. It's going to be an equation or a statement. So now, let's look at a composite. This is saying g of f of x. So anywhere in my function g that there is an x, this time we're going to replace it with f of x, this whole function. So what I really have is g of x squared plus 3. Because x squared plus 3 is f of x. Once I rewrite it like this, it's no different than all the ones up here. I'm simply going to replace any x in my equation g with x squared plus 3. This 2 on the outside, remember, needs to go to both terms inside. So 2x squared plus 6, and then minus 4, so 2x squared plus 2. Again, because there's not a number I'm plugging in, my answer is not a number. I ended up with an expression. All right, so that is a composite. So let's try some more. We are given f of x equals 3x plus 2 and g of x equals negative f of x plus 26. The g's on the outside, so g of f of x. Let's rewrite that. We're really saying g of, what is f of x? 3x plus 2. Once I have it written like this, we know that this means go to my function g, and anywhere that there's an x, replace it with 3x plus 2. Now, distribute near negative 5. So negative 5 times 3x gives me a negative 15x. Negative 5 times 2 gives me a negative 10. And then I'm still adding this 26 on the end. So negative 15x plus 16 when I combine my like terms. On B, it's saying f of g of x. So now we're reversing these. We're saying f of, and what is g of x? Negative 5x plus 26. The concept is still the same. We're just plugging it in to the other equation. So this time, anywhere in my function f that I have an x, I'm going to replace it with the negative 5x plus 26. So 3, negative 5x plus 26, and then plus 2. Same idea, you still have to distribute that 3 to everything inside of the parentheses. So 3 times negative 5x gives me a negative 15x. 3 times 26 gives me 78. And then I'm still adding that 2. Once I combine my like terms, negative 15x plus 80. Okay? Alright, let's try another one. This time we're going to have a squared in our equation, which doesn't change the process. I'm still substituting an equation in to my function, but when I square something, I do need to be careful of how I distribute that term. So right here, g of h of x, which is really g of, well, what is h of x? X squared minus 10. So anywhere in my function g that there is an x, I'm going to replace it with that x squared minus 10. Okay. Well, when I combine my like terms, I just end up with x squared minus 14. So this way wasn't too hard. Now over here, when I'm going to plug g into h, it is going to be a little different because of that squared term. So we're taking h of g, but what is g? X minus 4. So this is telling me anywhere in my function h that there is an x, I'm going to replace it with x minus 4. Now, when I have x minus 4 squared, this squared, according to my exponent rule, tells me how many times this base is being multiplied by itself. So if it's 2, I really have x minus 4 times x minus 4. I need to FOIL or double distribute this. So x times x times a negative 4, negative 4 times x, and a negative 4 times a negative 4. And then don't forget to carry your minus 10. Now I'm going to combine any of my like terms that I may have. So this is the only x squared I have. But I have minus 4x is going to give me minus 8x. I have plus 16 minus 10. It's going to leave me with a positive 6. Alright, so anytime there is a squared in one of your functions, you have to be careful when you're plugging things in. I can't just say that this is x squared minus 16 and distribute the squared through. It does not work like that with subtraction or addition. Okay? Let's look at number 3. I have h of x equals x minus 6 and g of x equals x squared plus 6x minus 2. So again, I have a quadratic, which means I'm going to have to be careful when I plug that value in. So g of h of x is really saying g of h, and let's look up here, h is x minus 6. So this is telling me, go to your function g, anywhere in there that there's an x, you have to replace it with x minus 6. So this one, not only does it have a squared term, but it has an x in two different spots. You must replace both x's with that x minus 6. So I'm going to get x minus 6 squared plus 6 times x minus 6, and then minus 2 at the end. I have to replace both x's. All right, again, just like we did up here, when we say x minus 6 squared, that really means I have x minus 6 times x minus 6. So I'm going to have to FOIL or double distribute that, but then right here, I'm distributing this 6 through, so 6 times x gives me 6x, 6 times a negative 6 gives me a negative 36, and I still have this minus 2 at the end. Now I need to go ahead and distribute this, so x squared minus 6x minus 6x plus 36. Then I have the remaining terms. So let's go through and combine any like terms that I might have. This is my only squared. I have a negative 6x, a negative 6x, and a positive 6x. This and this are going to cancel each other out. So I have a negative 6x. I have a positive 36 and a negative 36. So they cancel each other out. So I'm just left with a minus 2. Okay. So that one was a lot of work, but again, anytime we have a squared term in there, we are going to have to double distribute or FOIL that first term. And if we have more than one x in our equation, we have to go ahead and plug that function in for both x's, so it does create a little more work. Now, if we're going to do h of g of x, we're doing h of, and then g is x squared plus 6x minus 2. So I'm going to go to my function h, and anywhere that there's an x, I'm going to substitute in x squared plus 6x minus 2. So I have x squared plus 6x minus 2, and then minus 6. My only like terms that I can combine on this one are the negative 2 and the negative 6. So I end up with x squared plus 6x minus 8. All right. Last one. This time, if you look, we still are given an f of x and a g of x, but if we look down here, we're actually finding g of f of negative 3. So since we are plugging a number into our functions, our overall answer should also be a number. We just have to do things in order here. So when this says g of f of negative 3, I have to start on the inside. So this says f of negative 3. So let's go ahead and find f of negative 3. That means go to my function f, and anywhere that there's an x, replace it with negative 3. So 5 times negative 3 is a negative 15. So that means this whole inside right here is really a negative 15. So instead of writing it as g of f of negative 3, we just found that f of negative 3 is negative 15. So now I have g of negative 15. Well, that's telling me go to my function g, and anywhere that there's an x, replace it with negative 15. Okay. So then I'm going to actually square my negative 15, and remember it's a negative 15 times a negative 15, so I get a positive 225